All right, Math 8. I don't know if anybody saw the mistake that I made with this problem, number 3. Miss Flatten pointed it out to me. I worked out x plus 3y equals 0. And when I worked it out, I wrote it so sloppily that I thought my 3y was a 7. I mean, it works out just the same for the most part. It's just that instead of it being 1/7, it's going to be 1/3. But that was my fault. Good catch, Miss Flatten. I can't write to save my life. I'm going to go over a couple of more problems really quickly just to go on with these so you can start to figure out these on your own. Number 4, Ben says the system of equation had one solution. Is he correct? Explain. Ben is wrong. Can anybody tell me why Ben is wrong in this one? And it does not have one solution for this problem, number 4. I'll pause. You can pause it while you work on it and figure it out. You don't need to pause it. The reason I can tell you without even doing anything, they have the same value in front of the x. They both have the same slope, 1/4. That means they are both traveling up 1, right 4, up 1, right 4. But they have different y-intercepts. So that means one of them is going to meet at -4. The other one's going to meet at -14, but they're both going to travel in the same path and never intersect. So there is not one solution. There are 0 solutions for number 4. All righty. So really quick, if you see the same value for your slope in a problem, gone. Don't worry about it. No worries. There is no intersection as long as they don't have the same y-intercept. Now, if they had the same y-intercept, that'd be a different story. Okay, that means that they would have unlimited because they're the same stinking line. They meet all over the place. Now, number 5, they give you 2 equations. You've got to isolate the y value in this. Move the -6 to the other side, divide by 18. Move the -12, divide by -36. Okay, I can look at this right now and tell you how many solutions does this one have? 1. It has 1. They're not going to have the same value in front of this problem. I don't even need to do the work. I know it's going to be 1, but I'm going to do it for you just because I'm a nice guy, just to show you. Okay, when I move the -6 to the other side, it becomes 18y is equal to 6x plus 264. Okay, that's what it turns into. Divide by 18. I don't even care what 264 divided by 18 is right now. I'm just going to look at the slope. It turns into 1/3 x. Why? Because 6 and 18 are both divisible by 6. It reduces to 1/3. I'm not going to leave it at 6/18. That's horrible. Now the other one, when I move the -12 to the other side, it becomes positive, but I'm left with a -36. Y equals 12x. If that's the case, I divide by a -36. It cancels out. Divide by a -36. Y is equal to a -1/3 x. Now, I don't even care what my y-intercept is in this one. If all they're asking me is how many solutions, it's not asking me what the solution is. It's just asking me how many solutions I've got. I've got a negative slope for this one. I've got a positive slope for that one. I don't care about anything else. I know that it's going to have one solution. I know because it's just going, I know they're not parallel, so I know they're not going to go on forever and never touch. And I know that they're not the same line because one of them is negative, one's positive, so they're not going to have infinite. So there's only 3 choices, 1, 0, or infinite solutions. So infinite's gone, 0's gone. The only one left is 1 solution. Now, over to number 6. How many solutions does number 6 have? Well, I look at it. Do they have the same slope? No, they don't have the same slope. So automatically, 1 solution. Doesn't matter that my y-intercepts, this is just telling me what my intersection is, where they cross, what my answer is. I'm looking at how many solutions. It doesn't ask me what the solution is. It asks me how many solutions. It's either 1, 0, or infinite. Okay? 0 and infinite have to have the same slope. 1 doesn't matter. They are not the same slopes. They're close, but no cigar. They are not. So this one, one solution. This one solution. Now, as we go down, some people had some questions for me on number 7. Oh, I don't know how to do this one. They use decimals. What kind of jerk problem gives you decimals in it? But if you work out just one little tweak, you divide 11.2 by 7. You have to isolate the y. You can't have something over here with the y. So if I divide everything over here by 7, 11.2 divided by 7 is 1.6. 28 divided by 7 is 4. Train A, train B have exactly the same formula. Y is equal to 1.6x plus 4. System of equations, blah, 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 blah. What conclusion can you make about this system? Interpret the results. I'm going to tell you that these two stinking trains are moving on the same track at the same direction at the same time. There's only one of two things. They're either one on top of the other, or train A and train B are the same train. Okay, so I don't know. That's all I get from train A and train B. Why you would use trains for this? Maybe planes that were flying on different latitudes, or not latitudes, but different heights, different elevations. But Jiminy Christmas, there's two trains on the same path in the same direction. They're going to run each other. They're going to be one on top of the other. Okay? Does that make sense? Now with this one and number 9, a little higher order thing. This one especially is a little tricky because you've got a lot of variables. It's formulas. But number 8, you have to isolate the y's in both of them. Move the x's over, divide by the coefficient of the y's, and work those out. That should be what you work for here. And just get used to working and maneuvering and manipulating the numbers to get the y's all alone. Okay, hope that helps you with 5-1. We're going to be moving to 5-2 tomorrow, which is you solving systems of equations by graphing. You're going to be graphing a bunch of problems. You've got the paper that you'll just print it out and you'll graph right on them. I'll go over a couple with you and you'll get that done probably by Wednesday night, Thursday morning. So, and really not that tough. This one we'll work on and go over the rest of it tomorrow. Have a good night, people. Sorry this is so late.